This is Physics 1060, Descriptive Astronomy, Lab 9 Hints. So in Lab 9 we're going to try to figure out the age of the universe using Hubble's law. Now this lab first uses University of Washington's Virtual Astronomy Lab, and so we're using a lot of things from that on the web. But this lab is actually more like what a real astronomer would do than any other lab that we have. So the first few pages essentially just explain the background and theory and really what you're doing. So try to read through it, and I'll show you step by step once we get to the actual data measurement of how that's done. Now what we're going to be doing is we're going to first be looking at pictures. Now this is a picture of galaxy 1357. And what we're going to be doing is using the mouse to figure out where the edges of the galaxy are. Now, it's up to you to figure out where you think the edges of the galaxy are, and it doesn't matter how you do it as long as you're consistent. So for example, two different ways you can do it is, in this picture, I've chosen the two spots. I have to click one on one side of the long edge of the galaxy and one on the other side of the long edge of the galaxy. By the long edge, I mean the galaxy is not circular, it's sort of elliptical, and so I'm choosing the longest distance across that I can get. Now here the red dots show the edges of just where the blackest part of the galaxy is, and that's alright. Off to the side here, the green dots are another way of measuring it, which is the edge of where you can see those very faint spiral arms in the picture. Now I use the green ones. Again, it doesn't necessarily say that's more correct than the other. It's just I want you to be consistent when you're making your measurements. And after we do that, on the web page you'll be clicking the pictures, and it's going to tell you some pixel locations, and we're going to enter those in the spreadsheet. The next thing you need to do for each galaxy is look at the spectra. We've talked about continuous spectra and absorption spectra and emission spectra, and what they look like, just looking at sort of visible light with black bars instead of that nice rainbow spectrum in the background. But this is what a scientist would actually measure here. Here is an absorption spectra, and I'm looking at, on this axis, the relative intensity. That just means how bright the light is. And on here is the wavelength. And the wavelength here we're measuring in angstroms. 1 angstrom is 10 to the minus 10 meters. It's just another unit. And so I've got this spectrum, and I have this intensity curve for it, but there's two dips in the intensity curve. Those are the absorption lines. We have a calcium K and calcium H absorption lines. And the black lines down here tell us where they would be if everything was stationary, what we would measure in a lab. And we see that they're shifted slightly, and that's this redshift due to the motion of the galaxy. And all you're going to do is click very carefully at the very bottom of that peak, and it's going to give you an exact measurement. You'll write that down or put it directly into your Excel spreadsheet, and then you'll click as carefully as you can at the bottom of the next one and take that measurement. And then there's also an emission spectra given. And this is the hydrogen alpha spectra, and it should be at 65, 62.8 angstroms right here. We notice it's also shifted, and so what we'll do is we'll click right at the top of that spectra, and it will also give us a measurement. We'll record all these, and the spreadsheet has all the calculations done for us. All we have to do is enter that data, and it will tell us the distance to the object. So, on the Angel web page, you have a Hubble's Law data sheet. It's an Excel worksheet. Open it up. Ignore any errors that you see right away. There's going to be columns that I've highlighted yellow. Those are the columns that we're going to be entering data. So the first thing is click on this galaxy list in the PDF, and it should open the University of Washington data page. And you'll choose a galaxy from the list. So here I've opened up the web page, and I will move over. I'll choose NGC 1357. Now I have the image. I'm going to click on one side, click on the other side. When I do, I'll go over and I'll record then the x1, y1, x2, y2, and those are just the pixel measurements of this. And this tells me the angular size is 0.967 milliradians. That'll actually be calculated in the Excel spreadsheet for you. Be sure and record this information, or else you'll have to try again. So once I've recorded that data, now the next thing I need to do is record the galaxy spectrum, and there's another link on that same web page. So again, I open up, I click back, so I get to the same list, and now off to the side I see the spectra, and I'll click on the spectra, and there's the spectrum. And now I click right at the bottom of the K, and there at the bottom it tells me exactly what the wavelength of that, 3,964.5 angstroms. Very carefully write that down and then click on the other one. It'll tell you, in this case, it's 4,001 angstroms. Then move over to the emission spectra, click on the hydrogen alpha, and it will tell you what that is, 6610.6. Now you're done with this, and we can move on to the next galaxy. Once I've done this for all the galaxies, I need to make sure this is entered in the Excel spreadsheet. Now you can write this all down on a piece of paper and enter it later. I kind of like just to have the Excel spreadsheet open in the background and just type the data in as I measure it. So now we have our Excel spreadsheet. We notice at the top I've got the highlighted in yellow. These are the places where you're going to put your data. And down this side is all the different galaxies that we will choose. And the Excel spreadsheet will calculate everything, and in the end what we want is the distance and the recessional velocity, and that's what's going to be plotted in the graph below on the spreadsheet. So I just move over, I type in my x1 location, move over, I type in my x2 location, and move over my this is the x2 and the y2 location. And it shows us here the exact angular size that we had before. .9676 angstroms. Now I need to put my calcium K emission or absorption spectra. I put my calcium H absorption spectra. And move over in my hydrogen emission spectra. And when I'm done, it tells me the distance. It's 23 megaparsecs, and its radial velocity. Now, if I look up in a book somewhere, the actual distance to this galaxy was 28 megaparsecs. I'm off slightly. That's okay. We're not really trying to do publishable data here. What I really want you to do is see the kind of measurements that an actual astronomer would do. And this is exactly what they would do. They would look at the data, they would try to determine as best as they could the angular size and on the picture that they have of the galaxy, measure all the emission absorption spectra, and get some data out of it. When you're done, the graph should automatically update. If not, in the directions is how to update the graph, and then it's going to plot all that, and it'll calculate the slope for you, and that slope is going to be the Hubble constant. So once we know the Hubble constant, then we can calculate the age of the universe. And I have an example calculation. Let's say that you have in your spreadsheet you measured 75 kilometers per second per megaparsec. So that's your Hubble constant, 75. That's the number you need to worry about. So first we're going to find the inverse of it, so 1 over 75, which is 1.33 times 10 to the minus 2. We multiply by 3.09 times 10 to the 19th, and that gets rid of all the distance units, and so we're left with just seconds. This is the age of the universe in seconds. We divide by 3.16 times 10 to the 7th seconds a year, and we'll get the number of years. So we get 1.3 times 10 to the 10th years, or 13 billion years. So after you've done that calculation, If you have problems, post something in the discussion board. I can help you with that. Copy these questions into a Word document. Answer the questions as best as you can. Scan everything in as a PDF as we've done before and turn it in on Angel.